Prior to 1958, we knew what DNA was, we knew what it looked like. However, we did not know how it replicated, what its method of replication was. Now at the time, there were three hypotheses for how DNA replicated. The first was conservative. The two original strands would be replicated completely, forming another complete new strand, while the two original strands were maintained throughout the generations. Dispersive replication was the two original strands first separated, and they were added to two new strands each, and then these were replicated throughout the rest of the generations. Semi-conservative was the two original strands separated as in dispersive. However, the original strands were then added to a new strand, whereas the old new strand was now added to another new strand, creating what you see before you. Now, Meselson and Stahl attempted to figure out which of these three methods of replication was actually employed by DNA. So, using the fact that nitrogen-15 is by nature heavier than nitrogen-14, they decided to replicate E. coli in a nitrogen-15 medium so that all of their DNA would be nitrogen-15 and heavier than nitrogen-14. They then centrifuged the DNA off and weighed it. They checked its density, and they got a high weight. They then introduced the E. coli to a nitrogen-14 medium, where after one replication, they centrifuged off the DNA, and they found that it was lighter than the original DNA in the nitrogen-15 environment. A second replication underwent, and they observed that the same weight was still present in addition to an even lighter weight. Now, notice how these correspond to the generations in a semi-conservative replication, where in the original generation, there's only one weight. The second generation, there's one weight that is lighter. And in the third generation, there are two weights, each lighter than the first, while maintaining one of the weights from the first replication. Thus, Meselson and Stahl managed to figure out that semi-conservative replication was the method of DNA's replication.